So we have equations that we've been talking about, and we've only been talking about square roots, right, in terms of graphing? Okay, so today we're gonna switch over to cube roots, which are actually, I think, easier in some ways. So the cube roots are gonna look like this. They look like a letter S. Your domain and range for these graphs is gonna be all real numbers. So that's the nice thing. You don't even have to think twice about it like, ooh, is there a restriction? No, there's not. So eventually it's gonna, like, this is the walk like the Egyptian graph. I have all my graphs named. So it's gonna go both ways and hit all X's, and it's gonna go up and down and hit all Y's. So these are always all real numbers for both your, is somebody trying to maybe? Okay, I'm just making sure it's somebody in here, not somebody from 6 hours or another hour yesterday. Okay. Alright. So the good news is we can also graph these graphs on our computers, on Desmos. So the end behavior for both sides is that it's going to head toward infinity. I'm never going to ask you this on a quiz or a test, but as x heads toward positive infinity, remember this is as you go to the right on your graph, y also approaches positive infinity. So as you go to the right, it goes up, yep. As you go to the left, it goes down. So that's why it's going to hit all the things. So as you go to the right, it goes up. As you go to the left, it goes down. Okay, take a look at this graph. Do you see any type of symmetry? Any way that you see some commonalities where parts of it look the same? What does your gut tell you if I say, is there symmetry? Meaning, like, is there some connection between different parts of the graph that look the same? I'm going to say yes. So yes, we have symmetry, and in this case, it is point symmetry. Do you see how there's a point right here in the center of all this? And if I were to rotate an arm of the graph around, it would land back on top of itself. Where does my graph touch both the x and the y axis? 0, 0. Okay, so those are our different things that are important about the graph. Now take a look at this. Do you see how this looks way more involved? So this is the parent function. This is our toned down version of the function, but then this one got a little wild. So we've got an A out front, and A is going to be your stretch or compress. It's got a minus H underneath, that's going to shift you left or right. And then it's got a K out back, that's going to shift you up or down. So remember, those are things that we can add to change our graph. Because is every graph going to be the cubed root of x? No, you're going to have other stuff in there. I'm not going to make you graph the cubed root of x 5 times. So there's going to be other stuff in there that impacts it. And so the question is, well, how do those things impact it? So let's look down here at an example, and let's talk about how these different things impact it. So here's f of x. Here's my original equation. Remember, we change the name if something happens, and we've got a couple things that have happened. So here's my new equation. Ooh, this should be cubed root. Can you put a little 3 in there for me? Little baby 3. Okay. Do you see how we have a 1/2 out front that's being multiplied? Okay. So this is a vertical compression by 1/2. So this 1/2 is giving me a vertical compression. What would I call it if it had been a number like 5? Not a vertical compression, but a vertical stretch. Yeah. So compression means it's going to take that S, right? Remember I have this S? It's going to take that S and it's going to shrink it in vertically. If it had been a number bigger than 1, it's going to stretch it out vertically. Okay? All right. What about a +5 on the end? It's not with x. What do you think this plus 5 is going to do? What do you think the plus 5 on the end is going to do? So it's not under the root with x. It's out on its own. What are our thoughts about the plus 5 and how that might have an impact? And you can look back up here. There's notes up there. Think about when we've added or subtracted to an equation. What does that do? Is it what? Yeah, vertical translation. So let's unpack what that means. Vertical means what? Up, down, right? So we have up, down. And translation means a shift. So this is going to be a shift. And remember, it's positive, so we're going to go shift up 5. So when we have something with x, it does the opposite of what we would think. But when we have something out back, it does exactly what we would think. So if we go back up, hold on, I'm going to move my sheet back up. If we go back up, this word translation is the same as shift. So typically I use the word shift. But you can also use the word translation. Some people like the word slide because truly you're sliding the graph to a new location. So translation and shift are like a tomato-tomato situation. And a dilation, this is either a stretch or compression. It can't be both at the same time. That's not a thing. It's one or the other. But it's going to be a stretch or it's going to be a compression. So that's what a dilation is. So remember, it's a stretch if it's bigger than 1. So this would be a number bigger than 1. And this would be a number between 0 and 1. So it's some sort of fraction. So it could be 1/2, it could be 1/3. Negatives do something different. Those deal with reflections for us, so we're not even going to talk about negatives there. Okay? So we're just thinking about how the different things impact our graphs. Because then, when we go to graph it, if we have a 2 out front, it should stretch it. And if I don't get a graph that's stretched, I know something went wrong. Maybe I typed it in wrong, right? So this can kind of help us tell if our graphs are doing what they're supposed to do. Oh, sorry. It was not intentional. Good? You're good? Does anybody need the bottom part again? We're good? Okay, let's flip. Because this is what the majority of the work today is going to be you graphing. And the domain and range, I don't even need to graph it. What's it going to be for both of them? Yeah, I can write in my answer. I already know that one. I know that one. Right? All of them are all real numbers because it's going to go and have everything. So I can answer that question without even graphing. All right. Go to your Chromebooks, and I've got to show you where the cube root is. This one actually took me a minute to find. My pre-calc kids, or no, maybe it was algebra 2, I can't remember. One of them had to help me find it because I was like, I can't find it. And they're like, it's right here. And I was like, oh no.
It's tricky though, because we don't.
It's not what we grew up using.
A whole lot.
Yeah.
Yeah, like we have been graphing square roots all
Yep.
the days of our life. So.
Mhm. Well, and I'm used to my graphing calculator, so this is like technology that I don't use as much. And so my kids were like, it's right here. I'm like, oh, okay. I can do without your sass. Thank you. Okay.
It's not a sitcom, it's a soap opera.
Oh, Days of Our Lives, yeah.
These are.
These are. Okay, bring up this bottom thing again. Do you have that? Okay, so remember before we were using this thing, but do you see how this thing is only a square root? And I need a cubed root, and that's not going to help me. Do we agree with that? Okay. So I'm going to come over here. Do you see the word function? I'm going to click on the word function, and I am going to scroll. Do you see how this is a thing where you can scroll? I'm going to scroll all the way to the very bottom to where it says number theory. Do you see one of my very last things is the root? this is why I was like, good work for you for finding, but how would I have ever,
If we're graphing.
Right.
it should be up top.
right.
That's reasonable.
Okay, so click on that, and then look what you got over here. Do you see how it's letting me type in the root? So I can find a cubed root, I can find a 21st root, I can find whatever root I feel like. So type in your number. We need a 3. All right, what lives under the root for number 4? Okay, so let's type in x plus 4. Okay, so there's my s.
How
X
did you
plus
do the
4.
three part?
Oh.
So there should have, the little blinky cursor should have been up.
But
So if you go to functions, and you go all the way down, that's where it was. And so then when you click on it, yeah, do you see how you can type in the 3? Are we all here?
Yes. Same-
Michael,
same
I
thing.
can't tell by your face. Are you here? Are you fibbing, Bouncy Llama? No? Okay. All right, let's arrow to the right. So hit your arrow to the right key, because do you see how the root is following me?
Mhm.
Do I want that -1 under the root?
No.
I do not. So arrow to the right, so the root stops following you. And then I'd like you to type in -1. So again, that -1 should not be underneath. All right, now I've got some points on here that I can graph. So let me go ahead and write them down. Do you see how 2 of them have little, like, kind of gray over them, so I can just hover? So I've got a point at 0, 0.5 or 0.6? 0.6, because we're going to round that up. I'll show you my sheet in a minute. I can't get both of them under the screen at once. I've got a point at -3, 0. And then I'm actually going to find, do you see how this area is kind of important?
Yeah.
Mhm.
I'm going to find a point, let's see, can I get to -4?
No?
No? Close?
There
No?
should be a nice point. Right.
There should. Alright, well, I'm just going to write this one down. I'm going to go -4 and -1.1. So I kind of like to have, do you see how that's kind of the middle of the S? Right? The center where you would have the symmetry? I'm going to go right here. Is it -4, -1 if I...
I actually found another for another one,
Yeah,
yeah.
it is -4, -1. I love that even more. Okay. And then I'm going to come down here, I'm going to find another one. So do you see how I'm finding more than, yeah, I'm finding 4 points because I just want to make sure my picture looks good. Like, I want to make sure it matches. So I'm also going to graph -8, -2.6. Okay, so those are going to be my points. So again, I scrolled around to find those. And Griffin, you're telling me -4, -1 is a good one?
Oh, it is a thing.
It's a thing. Okay. So let me scratch that part out. So these are my points that I picked. Again, I kind of like to have some that are on the top part of the S, and then kind of in the middle, and then on the bottom. So sometimes I pick more than 3 points for these types of graphs. All right, so I'm over 0, and I'm up 0.6. So there's one of my points. I'm over -3, I'm up 0. I'm over -4, I'm down 1. And then I'm over -8, 5, 6, 7, 8. And I'm down -1, -2, I'm down here. And I want to draw in, that F-shaped graph. So again, we're not going to connect them with a line. I'm not going to get out like a ruler and make it all nice and straight and lovely. I'm going to get in there and use some curvature. How do we feel about that? Good?
And
Okay.
there's no shade.
There's no shading today. Nope,
Okay.
we're not going greater than, less than. Nope. This one kind of goes back to the domain range stuff, like what we had that first day. Okay? All right, so let's go to the next one. So I'm going to backspace out of everything, and I'm going to practice getting my cubed root again. So I went all the way back, And because it's kind of like one of those muscle memory things, right? Like if we do it a couple times, we kind of remember. So I'm going to go to functions. Look at all that crazy stuff that pops up. I'm going to go to functions, and I'm going to go all the way down to the bottom to the nth root. Oh, I have a cosine somehow. Oh my, how did that
We
jump?
win.
How'd that jump in there? We don't, no, not today. No. Okay, here we go. What kind, oh, I want something out front. I should have done that first. Okay, I'm backspacing again. Let's do the -2 first. Do you see how there's a -2 out front? Yeah, let's do that first. -2. After all that, getting rid of the cosine and all the things. All right, now I want to go to functions, but for real this time. I'm pretty sure. I can't be positive. Go down to the n again. What root do I want? What am I putting in the little index number spot? 3. And then what goes under? What's the only thing that's living under? X. Okay, there it is. Ooh, my S is facing the other way because of that negative. So we got some interesting kind of like reflection action going on. All right, ooh, I've got a point at 0, 0. I love that one. Ooh, what do you got? -2 what? I think I'm going to go up here and get one. Okay, if you found different ones, you can use the one you found. I'm going to go with this one. I'm going to go -2, and I'm going to go 2.5. I'm going to pick this one because I kind of like where it is on the curve, because it's kind of like a good spot to show me how quickly it's increasing. And then I'm guessing that because there's symmetry, if I go down here to, or if I go to +2, I should be at the same value, but negative. Like both my signs should switch. So do you see how if I go to +2, I'm at -2.5? So that shows me that symmetry. Okay, so let me put mine underneath so you can see the points I picked. So here are the ones I picked for this graph. Again, we're not shading for these. So I'm going to graph my point at -2 up 2.5. I've got a point at 0, 0. And then I'm over 2, and I'm down 1, 2.5. And then we've got our nice S-shaped graph that we're going to draw in. So in some ways, I think it's easier than yesterday because we don't have to worry about the shading. In other ways, it's a little trickier because you have to go through the process and maybe get a couple extra points. And you also have to go to kind of that special spot on your Desmos that you might not know exists, but now we do.